Hey everyone, welcome back to the College Algebra playlist. In the previous videos, we took a look at quadratic equations, and we learned several different methods for solving these types of equations. Alright, so in this video, I want to take everything we've learned about quadratic equations and apply it to some examples. Alright, so let's get started. Okay, here we go. Before we dive into the examples, I want to give a quick recap of everything we've looked at regarding quadratic equations. Alright? So we learned 4 methods for solving quadratic equations, right? There's factoring and using the square root property, alright? But notice that these methods only work sometimes, okay? Factoring only works when your expression is factorable, and using the square root property only works when your equation looks a certain way, alright? But we also learned about completing the square and using the quadratic formula. All right, these methods always work, no matter what your quadratic expression looks like. Okay? So the question is, which method should we use to solve quadratic equations? And the answer is it depends, all right? It depends on the situation. All right? Here's my advice. When you're solving a quadratic equation that looks like this, try factoring when a equals 1. All right? This expression could be factorable. All right? Also, use the square root property when the problem looks something like this. All right? In this scenario, you can take the square root of both sides and isolate x easily. All right? But complete the square only when the problem specifically asks us to use that method. All right? That's what we should do there. All right? And finally, use the quadratic formula when a does not equal 1. All right, when you have a leading coefficient other than 1. Use the quadratic formula. All right? So let's dive into the examples. Here we're asked to solve the quadratic equation x squared minus 9x plus 18 equals 0. All right? So remember my advice. When the leading coefficient is 1, we should try factoring. Okay, we should see if this thing is factorable. And it turns out in this case that it is factorable. All right? This factors as x minus 6 times x minus 3. Okay? So by the zero product property, that means that x minus 6 equals 0 or x minus 3 equals 0. All right? So let's solve this one on the left first. All right? Let's add 6 to both sides. All right? And that gives us x equals positive 6. Okay, so that's one solution. All right? Over here, let's add 3 to both sides. All right? Let's add 3 to both sides, and that'll give us x equals 3. Okay? So I have my two solutions. All right? We can visualize these solutions by plotting the curve y equals x squared minus 9x plus 18. Okay? This is what the curve looks like. And when we solve this blue equation here, right, when we solve x squared minus 9x plus 18 equals 0, we're setting y equal to 0, which means we're finding the x-intercepts of this parabola. All right? We found with this equation that x equals 3 and x equals 6. Okay, those are our two solutions. All right? Which means that those are the x-coordinates of the intercepts. All right, we have 3, 0 and 6, 0. All right, so that's what we're really doing when we solve an equation that looks like this. Okay? Let's move on to the next example. Here we're asked to solve the quadratic equation by completing the square. All right, so the problem asks us to use that method, so we'll go ahead and do it. All right, so what we want to do first is, well, normally what we want to do first is divide both sides by a. All right, but in this case, a is already equal to 1, so we have what we need there, so we don't need to divide both sides by anything. All right, we can just go ahead and take this 13 over to the other side. All right, let's add 13 to both sides. And that'll give us x squared minus 6x equals 13. Okay? And once we get to this point, we're ready to decide what we want to add to both sides to complete the square, right? To create a perfect square trinomial on the left-hand side. And remember, what we do is we take this number next to x, we divide it by 2, and then we square the whole thing. All right? So negative 6 over 2 is negative 3. All right, so we're going to square that to get 9. All right, so we're going to add 9 to both sides of the equation. All right, we'll add 9 to both sides in green here. All right, and on the right-hand side, that gives us 22. Okay, so we have x squared minus 6x plus 9 equals 22. Okay? The left-hand side can be factored, right? This is a perfect square trinomial, so it can be factored like this. And remember, the number that goes in this slot right here is always just going to be b over 2, right? It's always the number in parentheses here. Okay? So this is the factorization. Now we're ready to take the square root of both sides. All right? And when we do that, on the left-hand side, right, we get x minus 3. And on the right-hand side, we get plus or minus root 22. Okay? So let's add 3 to both sides to isolate x. And that gives us x equals 3 plus or minus root 22. Okay, so that's my answer. These are our two solutions, right? These values are the x-coordinates of the x-intercepts, all right? This is the curve we're looking at, and we're trying to find the x-coordinates of these blue points here when we solve this blue equation, all right? So for our two solutions, right, we got 3 plus root 22 and 3 minus root 22. So those are the coordinates that we're looking for, all right? Let's move on to the next example. All right. Here we're asked to determine the discriminant, state how many solutions there are, and describe the solutions. Do not solve. All right. So we're just looking at this thing on a meta level, right? And we're talking about the solutions and we're describing them, right? So we're describing the characteristics of the solutions. All right. A equals 3, B equals 5, and C equals negative 8 in this case. All right? So we can plug those values into the discriminant to calculate a value. And remember, the value tells us how the solutions behave. All right? So let's plug in our values, and this is what we get. All right? 5 squared minus 4 times 3 times negative 8. Okay? That equals 25 plus 12 times 8, which is 96, I believe. All right. So we get 25 plus 96. All right. And that equals 121. All right. So this number is greater than 0. All right. That tells us that our solutions are real numbers. All right. And 121 is a perfect square. Okay. So that means that the solutions are going to be real, and there's 2 of them, and they're both rational numbers, okay? So our answer to this question is 2 rational solutions, all right? So we used the discriminant to characterize the solutions, okay? Great. So let's move on to the next example. All right, example 60. Here we're asked to solve the quadratic equation. 2x squared minus 8x minus 5 equals 0. All right? This quadratic equation is already in standard form for us. Okay, so we can just write down our values for a, b, and c. All right? And then we'll use the quadratic formula to get our values for x. All right? So let's plug in b equals negative 8 right here. Okay, so we'll get negative 8 plus or minus the square root of negative 8 squared minus 4 times 2 times negative 5. All right, and that whole thing is all over 2a, right? 2 times 2 in this case. All right. So this simplifies a bit. All right, we have 8 plus or minus this business under the radical. Okay, and the whole thing is over 4. Okay. So under the radical, we get 104. All right, that's not a perfect square. but we can simplify it a bit. Okay, we can simplify this radical just a little bit. All right, we're going to get under the square root, right? This is the same thing as 4 times 26. Okay, 4 times 26 equals 104. All right, so we can break this into two different radicals, right? We get 8 plus or minus root 4 root 26. Okay, and that whole thing is over 4. All right, let's take this result to the top of the screen. Okay, the square root of 4 is just 2. Okay, so we can rewrite this as 8 plus or minus 2 root 26 over 4. Okay, and then we can break this up into two different fractions, right? That's the reverse process of getting a common denominator and condensing two fractions into one. All right, and these both reduce a bit, right? 8 over 4 is just 2, and 2 over 4 is 1 over 2. Okay, so these are my two solutions. 2 plus or minus root 26 over 2. All right? So we'd like to visualize these solutions as well. All right? Let's go ahead and do that on this screen here. Okay, here's our curve, and we're looking for the x-coordinates of the blue points. Okay? So this is the equation we're solving. All right? And we already found the solutions to be 2 plus root 26 over 2 and 2 minus root 26 over 2. All right, so those are the coordinates of the blue points. Okay. Let's move on to the next example. All right, here we're asked to solve the equation 2x plus 1 whole thing squared equals 9. All right, this equation looks a certain way, right? We've seen something that looks like this before. On the screen that said my advice, I said if the equation looks something like this, we should use the square root property to solve it right away. All right, so we can take the square root of both sides and isolate x fairly easily when the equation looks like this. Okay, so let's take the square root of both sides. All right, and that gives us 2x plus 1 on the left-hand side, and then on the right-hand side we have plus or minus 3. Okay, so let's isolate x here. All right, let's subtract 1 from both sides. All right, and that gives us 2x equals negative 1 plus or minus 3. Okay, and then to fully isolate x, right, we need to divide both sides of this equation by 2. Okay, so the 2's cancel on the left-hand side. All right. And that leaves us with x equals negative 1 plus or minus 3 over 2. So negative 1 plus 3, that's 2 over 2 is 1. And then negative 1 minus 3, that's negative 4 over 2 is negative 2. All right, so these are our two solutions. Okay? So this equation up here, we have to rearrange it to see what the curve looks like. We need to bring this 9 over to the other side and then set it equal to y. All right, so that's what our parabola is going to look like. All right, so we have y equals 2x plus 1 squared minus 9. Okay, and once again, we're finding the x-coordinates of the x-intercepts, right? We're setting y equal to 0. Okay, so we actually solved this equation. All right, we solved this version of it on the previous screen. All right, and we found that the solutions are given as x equals 1 and x equals negative 2. All right, so those are the coordinates of the points that we're looking for. Okay? Let's move on to our last example. All right, this is a word problem. It's an application in epidemiology, right, which is the study of diseases. This is a pretty interesting problem. All right? An epidemiological study of the spread of a certain influenza strain that hit a small school population found that the total number of students, S, who contracted the flu T days after it broke out, is given by the equation s equals negative t squared plus 13t plus 130, where t is in between 1 and 6. All right? Find the day that 160 students had the flu. All right? So the first thing we want to do with a word problem like this is make a picture. All right? We need to visualize what we're trying to do. All right? This is the curve that they gave us in the problem. All right? This is what the model looks like. All right? We're modeling the spread of a disease. All right? Where S, right? S is sort of like Y and T is sort of like X. Okay? S is the number of people infected and T is the number of days after the breakout. Okay? So this is the whole curve when we consider any value for t. All right, when t is between negative infinity and positive infinity, this is what the entire curve looks like. But in the problem, it was stated that t is only between 1 and 6. All right, so this is a restriction on something called the domain of the function. All right, we're not going to talk about domains and ranges of functions yet. All right, that's an upcoming topic. All right, so all we need to know for now is that t is restricted to these values. Okay, t has to be in between 1 and 6. All right, and we get this partial bit of the curve here. All right, so if we solve this equation, right, if we set s equal to 160 and solve the equation for t, all right, that's a quadratic equation, right? So we're going to get two answers, all right? But we only want to consider one of those answers, all right? One of those answers that's in between 1 and 6. All right? So find the day that 160 students had the flu. All right, we're going to plug in S equals 160. All right, that's the number of students. And then we're going to solve for t. All right, so we'll have a quadratic equation to solve. All right? We don't know how to solve it when it looks like this, right? We only know how to solve it when it's in standard form. All right, so let's subtract 160 from both sides. All right, we want this thing to be set equal to 0. All right? We get 0 equals this, all right? And in my next step, I'm just going to swap the left and right hand sides and color code my values for A, B, and C, all right? So now that we have a quadratic equation in standard form, we can use the quadratic formula to solve for t, all right? We plug in our values for A, B, and C, and this is what we get, all right? Let's take this result to the top of the screen. Okay, t equals this, all right, which equals this, okay? And look what happens under the radical. Okay, under the radical, we get a perfect square, all right? 169 minus 120, that's 49, all right? And the square root of 49 is equal to 7, all right? So we're going to get two values for t, all right? We're going to get 3 and 10, all right? But recall from the problem that t is restricted to this range here, all right? It has to be in between 1 and 6, okay? Which means that we can pick one of these values and ignore the other one, all right? We're going to ignore t equals 10 because it's outside of the domain, all right? And we'll get t equals 3, all right? So t equals 3 is my final solution. Right, and in the context of the problem, right, the way they word it, that's 3 days after the breakout of the influenza strain. All right, 3 days after that we had 160 students with the flu. Okay? That does it for this video. Thank you for watching, and like and subscribe.